So you have a mobile and you wish you could make a game there. Your search is over, as in this video I'll be showing you how to create this amazing game. Your character must move and avoid the enemies for as long as possible. You'll learn to create a complete 2D game with the Godot editor, structure a simple game project, move the player, spawn random enemies and count the score. Of course, a lot of more other things also. This course aims for beginners, intermediates, game developers, so you must watch the previous course in which I explain everything in detail. After watching it, you should be prepared to actually watch this one. The link of the previous course is in the description and in the pinned comment. So, the first thing you're gonna do is actually look for Godot in your Play Store. As you can see, you're gonna find both versions 3 and 4. For this course, we're gonna be using Godot Editor 4, but you should also be able to use the third version, okay? So you just click right here the version you want to install, click install, wait a couple of seconds, and that's it. As you can see here, I have installed the fourth version. Then what you're gonna do is to go to the first link in the description and you're gonna download the assets pack for the game. So you just download it and wait a couple of seconds. Now in Godot, we're gonna create a new project. In this case, I'm gonna name it Tutorial 2D, and you're gonna select a project path. In my case, I'm just gonna leave the default path. Well, not actually, I'm gonna change it to the downloads path right here, but you can select any path you want. And there I'm gonna create a new folder. Now I'm gonna click create and edit, and we'll have to wait a couple of seconds. Okay, once our project is created, we are gonna open our zip file that I give you the link in the description, and we are gonna extract, okay, all the assets. So this is gonna give us, as you can see, these two folders, which are the fonts around the art. So we are gonna select them both, click here move, and we're gonna move both folders to our project folder. In this case, as you can see, it's right here in my downloads, Tutorial 2D, and we just move them here. Finally, we come back to Godot. If no change is made, we are gonna close the application, okay? And now we are gonna open it again. And well, now as you can see here in our file system, we can see the art, which are the PNG files, the images. And we can also see the fonts, okay? Now we are gonna adjust the viewport width and height. So we're gonna go to project settings. Then here we're gonna scroll down until we see this option, display window. And these are the dimensions we should use, which are 480, sorry, and 720, okay? Then in the stretch mode, we're gonna set to viewport, sorry, mode to canvas items. Now let's create our player scene. In order to do this, we're gonna create a new scene, and well, our root node in this case is gonna be an area 2D, okay, like this. Remember that if this yellow overlay appear, you can just click here on the icon and that should disappear. So with this area 2D, we can detect objects that overlap or run into our player. Now we are gonna rename this node to player, like this. Once we have renamed it, we're gonna just save our scene, okay, like this. Now in our player, we're gonna add another node. In this case, it's gonna be animated sprite 2D. This one, okay? And okay, the animated sprite 2D will handle the appearance and animations for our player, okay? We can see that we are having this warning right here in our animated sprites. Also, we have this other in our player, but one thing first is to, in our animated sprite, in our animation and in our sprite frames, we have to create a new sprite frames, okay? This is a resource that is a list of animations that the player can display. Okay, so now if we click right here, this new menu is gonna be opened. Now we're gonna create our walk animation. So we are gonna rename this default one to walk right here, and here we will need to drag and drop two images. Remember that we have imported our resources, so here under our art you are gonna scroll down and find player gray up 1 and some other frames. So we're gonna drag and drop here firstly player gray up 1. Okay, with your touch input would be exactly the same thing, but then we're gonna make it with a walk 1 also. Okay, now if we click here the play icon, as you can see the animation starts playing. Okay, now here in this list we're also gonna click on this icon to create a new animation, and this other animation is gonna give it the name of up. Now we're gonna drag and drop the corresponding animations to the up animation. Is gonna be up 1 and then up 2. We can click also here play so that we could preview our animation, as you can see. And also then in our walk animation we're gonna drag and drop walk 1 and then walk 2 also. Again, if we play the animation, as you can see we see the animation. Then we're gonna resize our player a little bit. I'm gonna give it a scale of 0.5 in both axes. Finally, we're gonna add a collision shape to our player. Okay, and we are also gonna create here a shape of a capsule that I believe is gonna be the best one for this shape. So with this two orange or red dots, we can drag and drop them, drag them, and as you can see the shape is gonna be resized. So let's do it as similar as possible to the player. I believe something like that would be just okay. This will determine the player's hitbox or the bounds of its collision area. When you are finished, your player scene should look like this, okay? With a player, an animated sprite, and a collision shape. Okay, and now we just gonna go to scene, save scene, and we should be okay with that. Now in this next part, we're gonna be coding our player. In this lesson, we'll add player movement, animation, and set it up to detect collisions. To do so, we need to add some functionality that we can't get from a built-in node, so we'll add a script. In order to do this, we're gonna select our player, click here on this icon. This icon is used to actually create and attach a script to the selected node. Here, we're just gonna click here, create, and this is our script. We're gonna just delete these functions that we just created, both the process and the ready, okay, like this. And now we're gonna create two variables. Firstly, this variable speed will actually control our speed, how fast our player will move. And also we are gonna need another variable to store our screen size. Now in our function ready, that you should know that this function is called as soon as we start playing, we're gonna assign our screen size variable to our current viewport rect size. In order to do this, we're gonna write get viewport rect dot size. Now we can use the process function to define what the player will do. process is called every frame, so we'll use it to update elements of our game which we expect will change often. For the player we need to do the following. Firstly, we need to check for the input, then we are gonna move the player in that direction, and then finally we want to play the appropriate animation. Okay, but here we have a problem, let's say, that in most games you move with WASD, but of course if this game is gonna be played on our mobile device, we aren't gonna be able to actually move with a keyboard. So one solution to do that is to create some kind of UI. So in order to do this, I'm gonna create a new scene. This is gonna be a user interface, okay, and let's name it player UI, for example. And also we have to consider that the player would be able to move in 4 directions: up, down, left and right, which means we should create a total of 4 buttons. So that's exactly what we're gonna do. Of course you can adapt this input system to what you want to create, it doesn't really matter, but in my case I'm just gonna create 4 buttons, okay, button like this, create. Okay, as you can see I can here modify the size of this button because it is super small, so I'm just gonna resize it a little bit like this, for example. I think, okay, yeah, right here should be okay. Then by using here the move tool, we can actually move it down a little bit. So I'm gonna move it maybe right here, okay. Yeah, okay, then I can duplicate this node. To do this, you're gonna right click it and we should see a menu here. I mean we should hold the click, sorry. Okay, we should just hold it outside of the name so that we don't rename it. Okay, yes, that menu is the one that I need. And here we are just gonna click here duplicate. Then this second button I'm gonna move it to the right like this. Okay, and I'm even gonna zoom in a little bit. Perfect. Then again I'm gonna duplicate this second button, so I'm gonna hold the click, the touch, I mean, right here. Okay, well, I'm renaming it, so you should be careful with that. Here again duplicate. Now this third button we're gonna move it left like this, and we need one more button, okay, and in this case this is gonna be the top button, okay, like this should be okay. So with this button we would move left, with this down, right and up, okay. So let's actually rename them properly. So this is gonna be our up button. Then we also have here our left button. Here we have right button. And finally we have our down button, okay, down button, okay, like this. We are also gonna need to save this scene, and finally we're gonna create another scene. In this case our root node is just gonna be a normal node. We're gonna save it, but firstly let's rename it to main, save it as well. And then here firstly I'm gonna instantiate my player scene. Okay, so here as you can see I have my player, and if for example I do some kind of modification in my player, for example, I don't know, I toggle the collision shape. As you can see, once I save this scene and come back here, as you can see the collision shape, we can see it. Okay, so that's called a scene that you can then modify. So then here in our main, we also want to instantiate our player UI. So as you can see, we are just combining a bunch of elements. I can see here that our buttons would also need to be a little bit for here, so I will move them, but well, it will be just a waste of time. So what here we will need to do, in this case, we will need to enable the editable children functionality, because what we are gonna do is to actually connect the down, right, left and up button signals to our player script. So in this case, for example, on our up button we have some signals here, for example button down, button up, pressed, etc. So in this case I'm gonna connect button up to our player. Okay, so for example when here we press our up button, I'm just gonna print here button up pressed, for example. Okay, like this. Oh, let me correct this. Okay, so this is actually a button up okay, because let me explain it. We are gonna click here play, we're gonna select our main scene as our main one. So now when we play, remember that we have connected the up signal of the button, and the up signal is called when we release the click or the touch from our button. So this means that the signal will be called when I release the touch. Okay, so now I'm gonna do this 3 times. So I've already touched in this button once, so 2 and 3, which means that when I come back I should see 3 messages printed. Okay, this means that everything is working fine. So then we are also gonna need to connect the button down signal, and we will have to do the exact same thing but with all of the buttons. Okay, so for example with the down button, here we are gonna connect the button down and the button up as well, and the same thing with these 2 buttons. Okay, so this is how your code should look once you have all of your signals connected. Also, we are gonna need to create another variable here, which is gonna be our velocity, and here we are gonna start modifying our velocity variable. Okay, firstly on our up button down function, we're gonna modify this velocity variable to be velocity dot y plus equal 1. Okay, then on our this is gonna be minus equal 1. Then on our down button this is gonna be velocity dot y plus equal 1. Then on our left button down, our velocity dot x will be minus equal 1. And then finally on our I can't scroll down more here, on right button down in this case, and this is gonna be velocity dot x plus equal 1. Okay, so I cannot see it. Okay, but now yes I can. Once I have that, I'm gonna call my process function that we were talking about a few moments ago, and we're gonna say if our velocity dot length is greater than 0, which means that if we are actually moving, we are gonna set our velocity to velocity times speed. Also okay, here in our velocity, initially we're gonna set it to vector2 dot 0. Now it's time to actually move the player. In order to do this, we're gonna update our let me just scroll down a little bit so that you can actually read this. We're gonna update our position to be plus equal our velocity. That, remember that we set our velocity in this line, velocity times delta. Okay, finally we should also normalize the value of the velocity. Okay, now when we start playing, we can see something very weird. When we click here the button, well, as you can see, it just goes to the first direction we clicked. In this case, I clicked firstly right and it went directly right, and like it didn't come back and it just continued moving. So let's fix that. But well, as you can see, we checked that the movement system worked perfectly fine. So here we're gonna create a variable can move like this, that initially is gonna be set to false, and we are just gonna execute all the things inside our delta if our can move variable is actually true. Okay, like this. And then here we are just gonna click here the tab key. Okay, now if we play again, as you can see, we can't move. Okay, because in our code we said, okay, if can move is equal to true, we're gonna actually move the player, but as you can see, we've set it here to false. So we're gonna play, let's say, with this variable depending on our button signals. So firstly, when a button is up, okay, it means that we stopped pressing our button. What we are actually gonna do is to set the can move to false. Why? Because if we are no longer pressing our button, we don't want to move our player. Whereas if our button is down, we want to set our can move to true. Okay, and we're gonna do this with all the functions. So again, here we have a down signal. So as in this signal we would be pressing our button, we're gonna set our can move to true. And then here on up, okay, we're gonna set it to false. Okay, now okay, once we click a button, as you can see, it doesn't like continue in the same way, but as you can see, it doesn't matter. Like the button we press, it always goes to the same direction we pressed initially. Okay, so let's fix this. And well, the solution is even simpler that you may think. We should just modify the velocity, but instead of decreasing or increasing its value, depending on which button we are pressing, we are gonna change the value of the velocity considering this. For example, if we are pressing the up button, we are gonna set our velocity to vector2.up. Vector2.up, okay, is the exact same thing as saying vector2 0 1, okay, which means going up. Okay, and then here on button down we do the same thing. We set the velocity to vector2.down. Then when we press the left button, we set it to vector 2.left because we want to move on the left direction. And the same exact thing happens when we press the right button. So here you can take a look to how the player movement code finally ended up. We could, for example, delete here this line and also here this line also if you want, but that's not really necessary. So now when we play, this is the up button. As you can see, if I hold it, the player will continue going up, but it doesn't continue as it used to happen. If I click here the down button, it will go down. Here we have the right button and the left button, okay? And as you can see, everything works just fine. Now let's start actually managing our animation. So if we are moving, okay, that functionality is managed by this line of code. If velocity.length is greater than 0, we're gonna set our animated sprite to D of our player, and we're gonna play it, okay? Whereas if we aren't moving, okay, else we are gonna stop it playing, because if we aren't walking, for example, we don't want to play any kind of animation, we just want to stop it. Also, we should modify this if condition to say if our velocity is different, okay, this symbol means different. If velocity is different from vector 2.0, it means that we are actually moving, okay? Also, we should move this else condition to actually here, if we can't move, we want to stop playing the animations, okay? And well, be careful because here I move these lines over here, so I'm just gonna cut it. Here I should be able to cut it. Oh well, let's just copy it right here. Okay, and this line was position plus equals velocity times delta, and we can delete here. And now as you can see, if we aren't moving, the animation stops, it's not walking. But when we start pressing the buttons, as you can see, like the legs, let's say, are moving. Do you remember the screen size variable we created before? Well, let's use this because as you can see now in the game, if we play it, we can like go out of the screen, as you can see. And well, of course, we don't want that to happen. In order to do this, remember that we assign this variable value in our ready function to our viewport rect size. So we are gonna after we update the position, we're gonna say that our position will be equal to position, and here we are gonna use a built-in function that is clamp, okay? And here it takes a value, a minimum value, that is gonna be vector to 0, because our minimum value is gonna be 0, vector 2.0, and then we will need to set our maximum value, that's gonna be our screen size. So now, as you can see, I can't go out of the screen. Now that we can move the player, we need to also change which animation the animated sprite to be displaying based on its direction. Remember that here on our player, we have here in our animated sprite, we have our walk and our up animation. But we have a problem, because for example, if you remember, when we are playing, the player should be rotated when we are moving. For example, to the left, should be rotated, and again when it's moved to the in an up direction, I mean. So in order to do this, let's come back to the player script. And okay, let's just move here a little bit. Here inside our if we can move condition, if can move equals true, we're gonna say that if our velocity dot x is different from 0, okay, we are gonna grab our animated sprite 2D and then change its animation to walk, okay, walk like this. Then also we are gonna grab our animated sprite and we are gonna set our flip vertical to false. I'm gonna quickly explain these flip variables, okay. Here in our animated sprites, okay, we have some things that we should consider. Here in our offset we have the flip H, which is flip horizontal, and flip B, flip vertical. As you can see, it flips horizontally, this option, and this one flips vertically, our sprite. So in this line, it means that if we are moving either left or right, we are gonna set our animation to walk, and we are gonna disable, okay, our flip vertical because we are moving horizontally. Then, depending if we are moving right or left, we wanna toggle the flip horizontal, okay. So this is gonna be if our velocity dot x is less than 0, we are gonna actually set our flip H to true. Why? Because we are moving left, okay. And as you can see here, by default this sprite is like looking right. So if we are moving left, we want the sprite to look left. In order to do that, we just enable this flip H. But if we aren't moving left, if we are moving right, we are gonna actually disable the flip H, okay, because if we are moving right, we don't want to actually be flipping horizontally. Now, okay, as you can see, when we are moving up or down, our rotation or animation aren't changing, okay. But if we move left or right, as you can see, our rotation is changing, okay. Nice. Now remember that here we are checking if our velocity dot x is different to 0. So this means if we are moving horizontally. But what if we are moving vertically? So this is what we are gonna check in the following lines of code, okay. So if we aren't moving left and we are actually moving vertically, which means that our velocity dot y is different from 0, what we are gonna do is to play the up animation, okay, like this, animated sprite 2D dot animation will be equal to up, okay. Then we have to do the exact same thing that we have done on the x-axis. I mean, we need to flip it, but in this case vertically, okay. So in this case, this is gonna be if our velocity dot y is less than 0, we're gonna set our flip H to be true, okay. If not, we are gonna set it to false. Sorry, firstly, this is gonna be flip vertical, of course, right here. And then also if velocity of y is greater than 0, okay? And well, now as you can see, the rotations, animations, and everything is just working fine. Now it's time to prepare our player to detect collisions. We want our player node to detect when it's hit by an enemy, but we haven't made any enemies yet. That's okay, because we are going to use Godot's signal functionality to make it work. So let's go to the player script, and in the top of our script, under our extends statement, we're gonna create here a signal and name it hit. Now we will go to the player scene, and we're gonna notice that in our player node, in the signals, we can see the signal that we have just created. Now we will connect here the signal of body entered to our player script. So here we have the function that will be called when we detect a body entered. So what we are going to do here, firstly, I'm gonna hide the node. So basically the player disappears after being hit. Then we're gonna call our hit signal we created before and call the method emit, which basically will emit our signal. And then finally we want to disable our collision shape so that we don't trigger the hit signal more than once. So we're gonna call the collision shape. Then we're gonna call set deferred, and then we're gonna write here, let me just scroll down a little bit, disabled, and here to true. The last piece is to add a function we can call to reset the player when starting a new game. This function is gonna be called start, and it's gonna take a parameter named pause. Okay, then we're gonna set our position to the parameter of pause. Then we're gonna show the game object, and then we're gonna get the collision shape. Let me scroll down, the collision shape, and set the disabled property to false. All these functions, signals, etc. that we have created, we're gonna be using them in the next sections. Now it's time to make the enemies our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edges of the screen, choose a random direction, and move in a straight line. Let's create a new scene, and the root node in this case is gonna be a rigid body 2D. This one, we're gonna name this rigid body mob. We're gonna save this scene, and here we will need some more nodes. Firstly, an animated sprite 2D. Also, we will need a collision shape 2D. And finally, one, let's say, new node. It's the visible on screen notifier 2D. Basically, we can take a look here at the description. Detects when the node extents are visible on screen. Okay. So we can see here in the node, in our signals, we have two signals: screen enter and screen exit. So with this node, we can detect when the object enters or exits the screen. In the rigid body 2D, we're gonna set the gravity scale to 0. Okay. so the mob will not fall downward. In addition, under the collision shape to this section, we will have to uncheck in the where was it, in the ordering? No, it was sorry, it was in the rigid body, not in the collision shape. We're gonna scroll down, and here in collision object, collision, we're gonna uncheck the one inside the mask property, so this will ensure the mobs do not collide with each other. Okay, sorry, this one we have to uncheck. Now in our animated sprite, we're gonna create a new sprite frames. We're gonna open it, and this time we have 3 animations: fly, swim, and walk. So firstly, we have to select here the speed. In this case, it's gonna be 3 frames per second. Okay, I'm gonna do this so that that yellow thing doesn't appear. And well, here I'm gonna start renaming my animation. So this is gonna be fly. Okay, then the next one will be swim. Okay, remember to set the FPS to 3, and the last one will be walk. Okay, and again the FPS should be 3. Now to set our FPS, we have here in our folder all the frames. We have for example enemy flying 1, enemy flying 2, etc. So we're gonna go to fly, flying 1, flying 2, then swim, swim 1, swim 2, then walk, walking 1, and walking 2. We can actually preview our animation by clicking here. Okay, this is the walk animation, then we have our swim animation, and finally our fly animation. We'll select one of these animations randomly so that the mobs will have some variety. Now these enemies are a bit big, so in our animated sprite to this scale, we're gonna scale it to 0.75 in both axes. Okay, as in the player scene, we will have to add a capsule shape 2D in our collision shape. So capsule shape 2D. Then we will also have to rotate it, because if I want to resize it, as you can see, it's like not perfect for this shape. So what we can do here is to set the rotation degrees property to 90 under the transform. So here rotation and 90. Okay, now yes, we can resize it properly, and like this should be perfect. Now we're gonna add a script to our mob, an empty script. So firstly, let's create our ready function. Remember, the ready function is called as soon as we start playing. We're gonna create a new variable that is gonna be named mob types. Okay, then we're gonna assign to this variable the different animation names that we have created in our animated sprite 2D, and to do so, we're gonna call our animated sprite 2D. Then we're gonna call the sprite frames, and finally the method of get animation names. Okay, this returns an array containing all 3 animation names: walk, swim, and fly. We could try printing this value out, so print mob types. So we're gonna click on this icon over here. This icon is used to run the current scene, and the current scene is the mob scene. So as you can see here, I only see the mob and not the UI and the player. So now as you can see here in my output, I should see fly, swim and walk. Now when we check that everything working fine, we can delete this print statement. We then need to pick a random number between 0 and 2 to select one of these names from the list. In order to do so, firstly we're gonna call our animated sprite 2D, and we're gonna call the method play that is actually used to play an animation. As you can see here, I can select one of the 3 animations, but we don't want to always be playing the same animation, okay? We want to make it a little bit random. So in order to do so, we're gonna call our mob types, then square brackets, and here for example I could say here 0, 1 or 2 for example. So here in my array, the element 2 in this case is gonna be 0, 1, 2, so walk, because the index in arrays starts at 0. So if I say here 0, it's gonna be fly. If I say 1, it's gonna be playing swim. If I say 2, it's gonna be playing walking. But as I told you, I want to randomize this. And how do we do so? We type here randy, that is a method used to randomize things. Then we need this symbol, the percent symbol, and then we're gonna call here the mob types dot size. Okay. Firstly, randy and this symbol selects a random integer between 0 and n minus 1. N is this number right here. And the size of this array, as you can see, is 3 because we have 3 different elements. Minus 1 is 2. Basically, this is gonna take a number between 0 and 2. That's exactly what we need in order to select a random animation. We can see that, for example, when we start playing, the mob seems to be like moving around because of the animation. The last piece is to make the mobs delete themselves when they leave the screen. So we have to connect on our visible on-screen notifier 2D. We need to connect our screen exited signal. And it's very simple. To delete a node, we're gonna just call here queue_free. Okay, basically delete this object. With the player and enemies ready, in the next part we'll bring them together in a new scene. We'll make enemies spawn randomly around the game board and move forward, turning our project into a playable game. Okay, in our main scene, firstly we will have to add some other nodes. Firstly, we're gonna be adding a timer. Yes, it's basically a timer, okay? This first timer, I'm gonna name it mob timer. This is gonna to control how often mobs spawn. And we're gonna set the wait time to 0.5 seconds. Then we will need a second timer. In this case, this is gonna be the score timer to increment the score every second. So of course, as this will increase the score every second, the wait time will be 1 second. Finally, a third timer we will be using. It's gonna be named start timer. And well, this score start timer, the wait time will be 2, and we will also set the one-shot property of start timer to on. The one-shot option basically manages that when the timer finishes, isn't gonna start over and over again. Once it finishes, it's not gonna start again. Also, we will need another node that isn't gonna be a timer this time. It's gonna be a marker 2D. And as you can see, it's just a generic position. We are gonna name it start position like this, and we are gonna set the position, okay, to 240 450. Yeah, sorry, this is 240 450. Okay, the main node will be spawning new mobs, and we want them to appear at a random location on the edge of the screen. In order to do this, we will need to add another node. In this case, it's gonna be a path to the, okay, and well, this node, we're gonna be using it to create some the mobs, the enemies around the edges of our screen. We're gonna also rename it to mob path. As you can see here, when you select the mob path, we can see some options on this section. The one that, let's say, is important to us is this one, and that is gonna be used to add some points in our path. So in order to create, like, let's say, the most perfect possible path, we're gonna use these two options that they are basically they use grid snap and use smart snap. And now we are gonna create our path, and we want to draw the path in clockwise order, or our mobs will spawn pointing outwards instead of inwards. Okay, so having selected our mob path and these two options on, we're gonna click here on this green button, and we're gonna click here, okay, to add a point, then a second point right here, okay, then we will need a third point, okay, and this point this time is gonna be right here, and a fourth point right here, okay, and then finally we will click here to close the path. Okay, and as you can see, you should have your path like this. We can now disable these two options. Now that the path is defined, we will need to add in our mob path a path follow to this one. This node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path. In our main node, we're gonna attach a new script, again empty, and this time we're gonna create an export bar using that symbol, and we're gonna name it mob scene. Then we will have to say that this is a packed scene, again using these symbols. It's very important, the spelling. And basically, when we go back to the main node, we can see here in the inspector mob scene, and we can quick load our mob scene. Okay, so basically in this variable we have our mob scene stored that we're gonna be using then to instantiate it. Okay, also we will need here a score variable. Now we're gonna select our player node, and as you can see here, we see the hit signal we had created before. We want to make a new function named game over, which will handle what needs to happen when a game ends. So here we will connect the signal, but before connecting it, we have to set the receiver method, and in this case we aren't gonna name it onPlayerHit. we're gonna type here first. We're gonna erase everything, and here we're gonna type game underscore over, okay, and this should look like this. Then connect to our main node, and as you can see here, we have the game over function. Now on our game over, we're gonna call our score timer, and we're gonna stop it, okay. Then we will also call the move timer, and we are also gonna stop it. Finally, we will also have to create a new function. In this case, it's gonna be a new game function. And basically here, when there is a new game, we're gonna set our score to 0. And we're gonna call our player start function that we have created before, okay? And here we're gonna give the start position dot position. Finally, here we're gonna start our start timer. And well, so that you remember, we have in our player script a function named start that basically takes a position as a parameter and then sets our player position to the position given as a parameter. So it's basically that in this line, what we are doing is calling the start of our player, and then the position at which we will move our player will be our start position dot position, which means this position right here, okay? Now let's connect our timeout signals in all the 3 timers. So timeout here, and timeout here. Of course, check that you're connecting all the signals to the main script. So on our score timer timeout, basically we're gonna increment our score by 1, and then on our start timer timeout, we're gonna start firstly the move timer, and also we will need to start our score timer. Then in our move timer timeout method, we will create a move instance, pick a random starting position along the path to D, and set the move in motion. So firstly, we will need to create a new instance of the move scene. In order to do this, we will create a variable named move that is gonna say our move scene dot instantiate. Basically, what this line is gonna be doing here is to select here this button and here instantiate our move, okay, like this. But of course, as you can see, it doesn't have a position or something like that. So we will need to choose a random location on our path. So we will need another variable named move spawn location, and this is gonna be equal to get node. We will get the move path, and then we will also need to get the path follow to D. But before doing that, we should actually rename it to a move spawn location, okay, like this. So here we will write move spawn location. Now we'll create we will say that our move spawn location dot progress ratio will be equal to rand f, okay? I'm gonna explain this in a second. Now we will need another variable to set the mob's direction perpendicular to the path direction. And how do we do so? We create another variable named direction, and we're gonna set and we're gonna assign it to our mob spawn location dot rotation plus pi divided by 2. Then we need to set the mob's position to a random location, so our mob.position will be equal to our mob spawn location we have assigned earlier. Now we will also need to add some randomness to the direction. In order to do that, we're gonna say that our direction plus equal randf range minus pi divided by 4, and then pi divided by 4. And finally we will set our mob rotation to our direction. The next step is to choose the velocity for the mob. In this case, we're gonna create a new variable, velocity, and this is gonna be a vector2 variable, and again it's gonna be a randf range to get a float number between the range that we're gonna give it. In this case it's gonna be 150 and 250 on the x value, and on the y is just gonna be 0. Finally we're gonna set our, well, we don't modify the y direction because we only want to move it horizontally. And then we will set our mob.linear velocity to our velocity that we have created above dot rotated, that requires an angle, as you can see, and the angle is gonna be the direction. And finally we will need to spawn the mob by adding it to the main scene, so add child mob. So you may be asking, why pi here, and in some other parts of the code? In functions requiring angles, Godot uses radians, not degrees. Pi represents a half turn in radians, about 3.1415. Now in our ready function that I'm gonna create over here, I'm gonna call the new game function. So now let's try out our scene. As you can see, we can move and we have all the enemies coming right here that we have to dodge, obviously. Okay, basically I'm gonna collide with one and you're gonna see that our game I think is gonna crash. Yes, because we have to modify some things. Something important that you also have to consider is that here on our mob timer timeout, that is actually our mob spawner, I think I modified something before playing because I misspelled some things or I got confused with some functions, symbols, etc. So you can just copy this code right here. You can take a screenshot or whatever and check that everything is just like this. Also here in our game over, I misspelled mob timer, so I put mob time and it should be mob timer. Okay, let's try again. Here we have the enemies, we have to dodge them. Okay, they are collided, and as you can see, everything is working fine because I collide with it and there are no more mobs spawning. What's our game lacking? Some user interface. The final piece our game needs is a user interface, or also known as UI, to display things like score, a game over message, and a restart button. So let's create a new scene and we will add a canvas layer. okay, and I will name it HUD, which stands for Heads Up Display. This is an informational display that appears as an overlay on top of the game view. The canvas layer node lets us draw our UI elements on a layer above the rest of the game so that the information it displays isn't covered up by any game elements like the player or mobs. So as usual, we will have here to create some nodes. Firstly, we will need a label that is basically used to display text, and we will name it score label because this is gonna display our score. Then we will also need another label, but this time it's gonna be called message. Then we will also need a button we have used before in the course, a button to create the player UI, and we're gonna name it start button, okay? Finally, we will need another timer. In this case, I'm gonna name it message timer. We will click on our score label, okay, and as you can see, when I type here in our text, for example, hello, as you can see, the font is not super cool, so we're gonna modify that by scrolling down a little bit. Then here on theme overrides, we can see here fonts, and here we can load on our fonts. We have here the font that we have downloaded at the beginning. Then in our font sizes, we're gonna increase it to 64 like this, and always check this box. Also remember to save your scene, and we're gonna repeat the exact same process but in our message, which means going to theme overrides, fonts, and loading the font. Also in the font sizes, we're gonna check that and set it to 64. So now we're gonna set our score label text to 0, then our message to your game title. In my case, it's gonna be like the default name, that is Dodge the Creeps, like this. And finally, in our start button, I'm just gonna type here start. Now in my score label, I'm gonna set my horizontal and vertical alignment to center. Then I'm gonna do the same thing but in my message, both in center. I'm gonna set the auto wrap mode to word. Under control, we're gonna find here layout, transform. We're gonna set its X size to 480 to use the entire width of the screen. Then we will click here on this icon right here, and we're gonna center it on our screen. On our start button, we're gonna select it firstly. Now we're gonna go to layout, transform, and on our X, we're gonna set it to 200, and in our Y, it's gonna be 100. We're gonna set the anchor preset to center bottom, and then we're gonna set its Y position to 540, okay? Then finally on our score label, we're gonna set the anchor to top center, okay? Of course, you can modify this UI as you wish. Now on our message timer, we're gonna set the wait time to 2, okay? And we're gonna set the one shot property to on. Now we will add this script to the root node, again an empty script, and we're gonna create a new signal that's gonna be named start game. This signal is gonna be called when the button is pressed, when the start button is pressed. We now want to display the message temporarily, such as get ready or something like that. So we're gonna add the following code: func show message. We're gonna get there a parameter text that is gonna be the text that we're gonna display on our message. So we're gonna set our message text to the text as a parameter. I mean this text right here. Then we're gonna show the message, and finally we're gonna start our message timer. We also need to process what happens when the player loses. So again, we will need another function, in this case show game over. And here we will call the show message function with the message you want to show when you lose. In my case, it's gonna be game over. Then we will have to wait until the message timer has counted down. In order to do that, we'll write here a wait, and we want to wait until what? Until our message timer reaches, let's say, the timeout. Then we will set our message text to dodge the creeps, and what we are gonna show this message as well. Now we have to make a one-shot timer and wait for it to finish. So again, a wait, but we're gonna use get tree dot create timer of just 1 second, and again we're gonna connect the timeout, and after that second we're gonna show the start button. Now we will also need to create another function, update score, that is gonna take a score, and we're gonna use that score to update our score label text. But before setting our score to our text, we have to say str score. Why? Because our score is an integer, it's a number 1, 2, 3, 4, 5, etc. But our text of our score label requires a string. Okay, so we convert an int into a string using this method. Now we're gonna connect our start button pressed signal. Okay, and in this function we are gonna firstly hide our start button, and then we're gonna emit the signal that we created at the beginning, okay, because the game has started. Then we're gonna connect our message timer timeout, and in this case we are just gonna hide our message. Okay, so message hide, like this. Now let's instantiate our HUD into our main scene, like this. Open. Now we need to connect the HUD functionality to our main script. So in our HUD, we're gonna connect our start game to our main script, but the receiver method in this case is gonna be the new game function. Okay, new game, like this. Okay, now we have done so. remember that on our ready we used to call the new game there, but that's not necessary anymore as we are calling it on the receiver method. Okay, so we can just delete that. Also in our new game, we will have to update the score display and show the get ready message. So we are gonna call our HUD dot update score method that we have created before, and here we are gonna pass our score. Then we're gonna again call the HUD, but this time it's gonna be show message, and the message is gonna be get ready. Now let's go to the game over function, and here we need to call the corresponding HUD function, which is just the show game over. So HUD dot show game over. Now when we add 1 to our score, we want to also update our score in our user interface, so we call again HUD dot update score. Okay, in our ready function of our player we are gonna hide ourselves. So now when we start playing, as you can see, well, firstly we have to fix the start text, but besides that we also see here the buttons, the player buttons, so we also have to fix that. But well, let's try to play. Okay, get ready, and well, as you can see here we have a pretty functional game. Well, I lost there, but as you can see here the game restarts and we can play over and over again. However, I'm gonna show you something, and is that when I lose, as you can see, and I start playing again, the mobs aren't like eliminated, so we should probably delete them. I mean, for example, there are collide, and as you can see that these enemies aren't deleted, so we have to fix that. But okay, firstly let's go to the HUD scene and let's fix this start message. So start button, theme overrides, fonts. Here I'm gonna quick load the font, and in font sizes I'm gonna set it to I don't know, 32 maybe. So let's check it now, a little bit bigger, maybe 64 as well, should be okay. Yes. So now in order to fix the thing with the player UI, firstly on our main scene, when we show the get ready message, I will also like to show my player UI so that I could start moving, and then I want to hide it on my game over. So let me check here. I'm gonna call here player UI dot hide in this case. So now as you can see when I start playing, well, it's still there. So yes, because on the ready you have to hide it, of course. So here our main scene, I think I don't have here ready, I don't remember, no. So let's just here create our ready function that is called when we start playing, and I'm gonna hide it. Now as you can see, we don't see the player UI. When we click here start, we can see it and we can start moving. And well, now as you can see, game over, we can't move anymore. And when we click start, we can start moving again. As I was telling you a couple of minutes ago, if you play until game over and then start a new game right away, the creeps from the previous game may still be on the screen. It would be better if they all disappear at the start of a new game. So this is very simple to do. We're gonna go to the move scene. We're gonna select the move, go to node, groups, and here we're gonna add it to a new group. In this case, it's gonna be mobs. Now all mobs that we create will be in the mobs group, and we can just delete them whenever we want. So we're gonna come back to the script, to the main script, and on our new game we're gonna just erase them. In order to do so, we're gonna call getTree dot call group, and here firstly we need the group name, as you can see here is mobs, and then the method, and the method we want to call is q free, okay, free, like this. The call group function calls the named function on every node in a group. In this case, we are telling every mob to delete itself. Now let's start playing again. As you can see, I can move and everything like that. But when I collide, okay, and a new game starts, as you can see, all the mobs are deleted. Well, actually, when I click the start, they are all deleted, okay? But okay, I'm gonna do so, and let's see if I can catch this one. As you can see, it was deleted. Also, another thing that I think I've noticed is that if I die while moving and I start playing again, as you can see, it starts like going up. So let's fix that. Well, the solution is quite simple. On our start method in our player, we're gonna set our can't move to false, and then we're gonna set our velocity to vector 2.0. So now let's try it out. I can move as usual, and okay, here I lose while moving, and as you can see, my player doesn't goes on that direction, and everything seems to be working just fine. The game's mostly done at this point, but in the next and last section of the course, we'll polish it a bit by adding a background looping music. So firstly, the first thing I like to do is to change the background color, because that gray, I don't really like it. So we're gonna go to the main scene. So here we're gonna add on our main node a color rect, like this, and this is basically a node to create a color, and we're gonna make it the first node on our hierarchy to be drawn behind the other nodes. So as you can see, it only has one property, that is the color, and of course you can change this color to be whatever you want, but in my case the color I have is this one, okay? So I'm just gonna paste it right here, and well, this is the color, but as you can see, it doesn't fit like all the screen. So we're just gonna here select the anchor and full ratio. Now let's add a couple of sound effects. So we're gonna add to children of the main. These are gonna be audio stream player, okay, used to play audios, and one is gonna be our music, and other one, okay, is gonna be again another audio stream player, and in this case this is gonna be death sound. Now here on the stream, this is the audio that is gonna play. So we have here the music, so I'm gonna quick load. We have here house in a forest loop, so this is the music, and the death sound, we have it also like right here, game over, okay? All audio is automatically imported with the loop setting disabled. If you want the music to loop seamlessly, we will have to go here to the music. Now here click on this arrow, and we will select here make unique, and then click right here and turn on loop. Now we are gonna go to our scripts, and on our new game function we are gonna play our music. So this is gonna be music play, and in our game over we are gonna stop it. This is right here, so music stop. And also here in the game over we're gonna play the game over sound. Well, and that's how the final game would look like. So I hope you have enjoyed this amazing course. If you leave your like and subscription, I'll create more similar courses. If you have any idea for future courses, leave it in the comments. The game source code can be found in my Discord server if you wanna take a look. Finally, it's important to say that this course follows Godot's docs tutorial, but with some own modifications in order to, for example, modify the keyboard input to make it playable in mobiles. Now, have a good day and see you in the next one. Bye bye.